So, in general terms, we will be able to perform various tasks from this centralized node. New, deployment of new instances. The possibility of upgrades or rollbacks. To take backups and restores on the servers that we are going to be managing from this centralized node. Unlike what we have been managing, here we do not use Docker for what is the deployment of OMniLeads using Ansible in an automated way. We propose the use of another engine of containers. In this case, it is Podman. It is that implements the use of containers. Very, very closely related, quite similar to Docker. In fact, commands are pretty much the same. It has some differences that would not be the time to go into those technicalities. Just to tell you that it has been used, Podman has been chosen in this deployment format. Since great ability to handle containers using then we are not talking about Docker Compose, but we are going to talk about systemd. We are not talking about Docker plus Docker Compose, but we're going to talk about systemd and Podman. Why? Because, Podman is a technology very related to Red Hat and have worked to be able to orchestrate containers using systemd. So, we stop thinking in terms of Docker Compose, and we're going to start thinking in terms of systemd. This leaves it very, very close to what would be OMniLeads X, whereas we know everything was based on components that were managed through systemd. So in that sense, we would be even more formalized with the previous version. The architecture is the same. They are the same components that we have already presented, that we have already used in Docker Compose. Only now, each one of these components will have a file service, let's say inside TC systemd, system, where is going to be the declaration of the command that is going to initialize the containers. In turn also, each of these components will have a exclusive environment variables file that is referenced in the systemd file. Then, all this deployment that, as we will see, in addition, presents some new schemes since beyond of the all-in-one, that is to say, all the components running in a host. Through this format installation based on Ansible, we are going to be able to deploy also a cluster, horizontally separating these components on 3 Linux hosts in a way that allows isolation and scalability. And there is also a high availability format for on-premise environments, in which allows to deploy in high availability, where in case of failure of one of the hardware nodes, can the application respond on the other one? Here we have a little of what we've been talking about, this of the 3 formats in which the application can be deployed. Using Back, Podman, and systemd, these graphics seek to clarify what was telling you, where in OMniLeads, this would be the most similar format to what we already know using Docker Compose, where all components are deployed using a Linux server. But, instead of now doing Docker Compose up or down directly, we are talking about each container or containerized component that responds to a systemd command, which we are going to show how to through the use of Ansible and some more scripts. We are going to be able to implement all this that we mentioned. First, provisioning, or managing multiple instances of OMniLeads in parallel. even beyond the operating system, the cloud, or the physical location where the servers are, because we abstract via SSH. Declare how to connect via SSH to those servers, and Ansible does the rest. And also, well, remember that here we are going to be in an environment of systemd and podman, no longer Docker Compose, for container orchestration, and that we also handle different formats in which we can distribute the OMniLeads components in more than one host to achieve scalability and robustness in this of distributing the components in 3 Linux hosts according to its function. If it is going to be storage, processing, voice, or the web part, isn't it? And well, of course, the question of high availability, where, well, there are scenarios where it involves hardware redundancy at the hardware level to be able to deploy all this in on-premise environments. Well, with this introduction, I think that we will be fine. All this will become clearer when we start to all types of deployments.